Hello, everyone. Welcome to another Jakarta Tech Talk. Before we kick things off, I just wanted to take this opportunity to let you know that the 2025 Jakarta EE Developer Survey is now open. So when you have a quick little moment, click the QR, scan the QR code, and fill out the survey to participate today. Now, here we are. I have joining us today Grace Jensen, who will be presenting on the topic of becoming a cloud-native physician using metrics and traces to diagnose our cloud-native applications. If you have any questions throughout our presentation today, please feel free to put them in the chat or use the Ask a Questions tab. Without any further delay, Grace, over to you.
Fab, thank you so much. It's great to be back with the Jakarta community. And definitely go and check out that survey because it really helps define sort of the future of where we're going in the world of Java. So if you have 5 minutes, it's a massive help. So do go and check that out. I'm just going to share my screen so we can get started with the session today. Perfect. So for those of you who've not met me before, hi, it's lovely to meet you all. My name is Grace Jansen and I'm a developer advocate at IBM. I've been there for about 7 years now. Before that, I actually did a biology degree. So it's been a bit of a weird and wonderful route into technology, which is why I like to bring sort of biology sort of analogies into this world of tech and to use that to be able to help us navigate what can often be a very complex and complicated and sort of hidden world of cloud-native technologies and cloud-native Java. So today, as Serena said, we're going to be taking a look at how do we become cloud-native physicians? How can we use things like metrics and distributed traces to be able to effectively diagnose our cloud-native applications when they're out there in the wild, when they're deployed in production? So we're going to be taking a look at that today. So why have I chosen this analogy to medicine in this case? Why are we referring to doctors? What can we learn from the field of medicine to help us in this world of Java development and cloud-native application development? Well, actually, there's a lot of similarities between sort of medicine and being a doctor and software development. And you might be thinking, where's the similarities? So in medicine, we're often diagnosing with biometrics. So doctors have years and years and years of training taking a look at being able to understand what these metrics actually mean, especially when they're combined together. And that might be things like physical symptoms, written notes, it might be heart monitors, blood oxygen levels, and there's loads of different things that can sort of contribute and be combined together to be able to help doctors to diagnose conditions and syndromes and diseases from these biometrics. And actually we do something very similar in software development. So in software development, we're also diagnosing, but we're diagnosing applications instead of people. But we're also looking at metrics. So it might be things like app health, API requests, it might be memory consumption, or even things like duration of requests or number of users that are connected. There's lots of different data and metrics that we collect in software engineering to try to effectively diagnose, is our application behaving the way we expected it to behave when we're deploying it into production? But when you take a look at medicine, for example, there's a very big difference diagnosing an adult than there is diagnosing a baby, for example. And it's not necessarily the language barrier in terms of them being able to communicate that, but it's more around the fact that with an adult, adults understand the fact that context, this all-important context, can make a huge difference between being able to diagnose effectively and getting a condition wrong, for example, because the same symptoms can present themselves for multiple different diseases or conditions or syndromes. And really, it's that all-important context that adults can give, for example, that makes the difference. For example, if you have got a headache and you fell over the day before, maybe that's the cause of the headache instead of the headache being something more sinister or serious. So being able to explain, what's happened, has there been any changes in behavior and location in everyday habits? Do you have any sort of history of this within your family? Where's the pain? What does it feel like? How did this happen? Events prior to that, maybe exposure to harmful things. All of this context, adults understand is important to give to doctors and they're able to communicate that effectively. Babies, on the other hand, not so much. And so this is kind of the next step in our cloud native sort of observability, a cloud native sort of doctor, as we were talking about, to be able to add this all-important context in when we're trying to understand not just the biometrics, not just the metrics of what's happening to my application in real time, but why are those metrics happening? What's the root cause of that? And this is where we're starting to go sort of into that next level to be able to understand not just sort of a rough idea of what's going on, but really pinpointing it down to specific reasons, specific understandings of sort of how to be able to fix that problem when it's in production. So this is kind of that next step of becoming that cloud native doctor, combining those metrics with that context to be able to become effective in monitoring our applications. So when it comes to observability, how do we enable this effectively? We talked a bit about this and related it to that medicine analogy so far, but really there's three key steps, three sort of theoretical steps in implementing observability. So we've got things like instrument systems. So the first step here is to instrument the systems and applications to be able to actually collect that relevant data. So if we're not instrumenting our systems or our applications to be able to collect that data, we can't do steps 2 and 3. And that can include data like metrics, it can include traces and logs, lots of different metrics that we can collect. So that's step 1, instrumentation. Step 2 in this theory is once we've got that data, we need to be able to send that data to a separate external system so that we can store it and start to analyze it, so we can start to understand what's going on. And then step 3 is once we've stored it, once we've analyzed it, we need to actually understand it. So to do that, we can do things like visualizations, for example. We can have query capability and insights into that data we're collecting and into sort of what's going on as a whole with that system. So step 1, instrumentation, step 2, storage and analysis, and step 3, that visualizations and insights. So today in this session, we're just going to be focusing on this first step in terms of implementing observability in our system, and that's the instrumentation step. So how do we actually enable us to get this all-important metrics, logs, data, and that all-important context out of our application and our system through instrumentation? When it comes to instrumentation, there are 3 key pillars. So we've got logs, we've got metrics, and we've got distributed traces. And these are the 3 key types of data that we really want to be collecting from our application. Now, that's not to say this is an exhaustive list. There are other types of data out there that are also really useful in terms of instrumentation of our applications. And that can include things like end user monitoring, for example, and profiling. So understanding right deep down as to, where is your code spending time and how is it spending that time, and also understanding, what paths do our users take when utilizing our applications. I can see some comments of maybe people aren't able to get onto the stream. So Serena, if you're able just to take a look into that when you get a chance, I'd appreciate it.
Yes.
Perfect. Thank you. Hopefully people are able to get in soon. But yeah, so these are sort of different types of data that we can be collecting. In this session, we're just going to be focusing on those 3 key ones, which is the logs, metrics, and distributed traces. But if you want to check out some of the other types of data, they are being implemented by different open source specifications currently. So you can go and check them out. But we're just focusing on those core 3 for today. So starting with logs. I'm not going to spend too long on this one because you're probably already making use of this in your own applications today. So we've got logs. What we mean by logs is really sort of this higher level of information. It's usually time-stamped, so it normally is a representation of what's occurring at a particular point in time in your system. So it's a time-stamped message emitted by services or by other application components, normally containing quite high-level, coarser-grained information, normally about system behavior. So it might be things like an error or a warning, and typically they'd be stored in a set of log files. Now, the nice thing is that many different types of sort of application runtimes, as well as tools and technologies, enable this type of logs to be enabled in your application. Yeah, I can see some comments in the chat now. If you guys do have questions, please do put them in the chat because we will be answering them at the very end of this session today. So we've got logs. Logs are by far the easiest to generate. As I said, most languages, application frameworks, and libraries come with support for logging, and we utilize them very sort of excessively within software application to help with those sort of higher level messages being emitted to our system. So logs can be a really helpful sort of starting point to get information out of our system when it's in production. Then we've got metrics. So metrics kind of go that one step further, where logs were kind of that time-stamped message. So understanding our system at that particular point in time, metrics allow us to be able to understand what's going on in our system over a period of time. So it allows us to create sort of aggregations of numerical data, either about the infrastructure or as our application over this period of time. So we can start to see how our application is changing based on those metrics over time. We can start to see trends, start to understand, okay, what's the norm, and is my application varying from that norm? It includes things like system error rates, CPU utilization, and request rates as just examples of types of metrics that you might be collecting. The nice thing with metrics is that once they're collected, they're much more malleable to mathematical and probabilistic and statistical transformations. So we're able to do things like sampling, aggregation, summarization, and correlation on them. Understanding, sort of, again, getting that all-important understanding of, is my application behaving the way it's expected to? What's the norm, and is it varying from that? However, the biggest drawback with just using logs and metrics is that they're both system scoped. So it makes it really hard to be able to understand anything else other than what's actually happening inside a particular system. So we really want to take it that step further by introducing distributed tracing, which is that third pillar, to be able to address this problem of bringing visibility into the lifetime of a request as it goes between several different systems, so not being system scoped. And that's, as I said, where distributed tracing can help. That's why it's a key third pillar in how we instrument observability. So what is distributed tracing? Well, we call it distributed tracing because normally this happens in a distributed environment where we've got microservices deployed to the cloud, but you can also just refer to it as tracing. So tracing it's a monitoring technique that links the operations and the requests that are occurring between multiple different services. Essentially, it allows us to be able to trace, hence the name, trace the path of an end-to-end request as it moves from one service to another. So really, it allows us to be able to sort of pinpoint right down to specific errors or performance bottlenecks in individual services that might be negatively affecting the overall system performance. Without tracing, it can be really challenging to pinpoint the cause of performance problems in a distributed system. So it can really help us to improve the visibility of an application's health and enable sort of that all-important debugging behavior that can be really difficult, especially if it's hard to reproduce that error locally. So those are the three core pillars. When it comes to distributed tracing, this might be the one that might be new to you, and we're going to be focusing a bit more on it in this session today, because it's also the one that enables us to add that all-important context that we were talking about right at the start, making that difference between diagnosing an adult versus a baby in medicine. So we're going to take a look at distributed tracing, and for that, we're going to need to understand some key concepts. So I'm going to go through some of those key concepts here in the next few slides, just so we're all on the same page and understanding sort of the different elements to this distributed tracing. So the first is a trace. What is a trace? As I said, it's that sort of representation of multiple requests, and it normally consists of multiple spans. So you can see in my diagram here, I've got the trace in orange, and it's consisting of multiple spans, which are there in pink. Excuse me. So what's a span? A span is a representative of a single operation in a request. So it normally is something like a name. It includes things like a name, time-related data, log messages, any metadata that can give us information about what's occurring during that transaction. So it describes an operation of work that's taking place on a service. It's deliberately quite a broad sort of scope for this. So for example, it can include things like a web server responding to a HTTP request, or it can be as granular as a single invocation of a function. So it's got quite a broad definition. But essentially, we've got spans, and those spans come together to represent a trace. Now we've got the all-important context. So far, we've identified the components of a trace, but we haven't really described how these components are linked together. And this is where that all-important context comes in. So context is an immutable object. It's normally contained within the span data, and it helps us to be able to identify the unique request that each span is a part of. Typically, there'll be two values that the trace context has within it. So those two values are the trace ID, or the trace identifier, and the parent identifier, the parent ID. So you can see those represented in my diagram here. We've got the purple boxes, that's the context contained in that span data. And in that, you can see the trace ID and the parent ID. So the trace ID is the unique identifier that's generated in the root span. And essentially, it's designed to be able to allow us to be able to identify the entirety of the trace. So which spans belong to this particular trace. So this same trace identifier is used throughout the spans that are involved in this trace because it allows us to be able to link them together to understand they're all part of the same request. Then you've got the parent ID. The parent ID is the span ID of the parent that spawned the current operation. That's a lot of span and spawned in that definition. But essentially, if you look at the diagram, you can see an example here. So we start off in the browser application, and you can see the span ID for that is ABC123. So therefore, in the parent ID of the context, you can see it's also ABC123 because it's the parent, it's the span ID of the parent that spawned that current operation. Then if we go to the next piece of context, we can see that the parent ID changes because the parent has changed. So the span ID changes to be DEF456, which is from the API web server. You can see that reflected in the second context box there. So with these two values, the trace ID and the parent ID, what it allows us to do is for any given operation, it's possible for us to be able to work out where the originating root service was, and then to reconstruct all of the parent or the ancestor services in order that then led to the current operation. So by being able to create this very accurate tracing and understanding what went on, what work went on at every single point in that, it allows us to be able to have that effective debugging and to really pinpoint down those potential errors and bottlenecks. So those are the key pillars. We've got logs, we've got metrics, we've got traces, and tracing is really where we can utilize sort of that all-important context, and we can take it to that next level when we combine it with things like logs and metrics to create effective observability for our cloud-native applications. But how do we do that? We've gone over the theory, but what about actually practically getting sort of hands-on with this and enabling it in our own applications? And that's where we can take a look at open source specifications and technologies. So the first one we're going to take a look at is Open Telemetry. So in the past, the way in which we instrumented sort of our code would really vary because each observability backend would have its own instrumentation libraries, its own agents for emitting the data to the tools. So what this meant was there wasn't really one standard for us to be able to use to send data to an observability backend. And if a company then chose to switch which observability backend they were using, it meant you'd have to re-instrument all of the code and configure new agents just to be able to emit that telemetry data to that particular new tool. So the community came together and realized we needed a standard, and that's where the Open Telemetry project came about. Originally, it was a joint project between Splunk, Google, Microsoft, Amazon, and many other organizations, and it's now been donated to the Cloud Native Computing Foundation. It's actually the second largest number of contributors in the CNCF, just behind Kubernetes. So it is a really vibrant community, growing and constantly developing over time. So it's a super exciting place to be. What does it offer? It offers a pluggable architecture that enables you to be able to add in technology protocols and formats really easily by still having that open source standard. It supports open source projects and metrics formats like Prometheus, for example, and allows you to be able to store the data in a huge variety of different backends, including things like Jaeger and Zipkin, for example. So really, it's built out of high quality, ubiquitous, and portable telemetry, and enables you to have that effective observability. Originally, the Open Telemetry project came out of two other open source projects. So you might have heard of or come across things like Open Census or Open Tracing before. Open Tracing was a vendor-neutral API for sending telemetry data to an observability backend. But the difficulty with it was that it relied on developers implementing their own libraries to be able to actually meet the specification. Open Census, on the other hand, provided a set of language-specific libraries that developers could then use to instrument their code and send it to any of the supported backends they want. But what the community quickly realized was that by having Open Census and Open Tracing, there still wasn't one single standard. And so they brought the best parts of them together, deprecated those older projects, so they are now deprecated, and created from the best parts of them the Open Telemetry project to create that one single standard. So Open Telemetry, as I said, it enables that high quality, ubiquitous, and portable telemetry. It's a collection of tools and APIs and SDKs The important part to note here is that Open Telemetry does not give you a complete end-to-end observability backend system. It needs to be utilized in conjunction with things like Jaeger or Prometheus to be able to do the second and third steps we looked at in the theory behind how do we enable observability. This Open Telemetry really enables that first step, that instrumentation step. You still need those additional tools like Jaeger, like Prometheus, to be able to do the storage and analysis and the visualization, step 2 and 3. So don't think just by using Open Telemetry you can get all of that in one. You do still need to use it in conjunction with other tools and technologies. Just something to bear in mind there. The way that it works when it comes to architecturing an application and really getting that data out looks a little bit like this. So we've got our microservices in the top left-hand corner there. We've got our infrastructure in the bottom left-hand corner. And you can see we've got these arrows of data being collected and sent across to our central collector here. And that's got the acronym OTLP. We're in software development. We absolutely love acronyms. I swear it's like speaking Latin half the time. This is short for the Open Telemetry Protocol. So OTLP, or the Open Telemetry Protocol, is a specification, and that's really describing the encoding, the transport, and the delivery mechanism of that telemetry data between our telemetry sources, any intermediate nodes we might have, like this collector here, and our telemetry backends, which are on the right-hand side of this diagram. So that's kind of how it would look in your application. You might be wondering, what is this collector in the middle and why do I need it? So this collector is a vendor-agnostic implementation on how to receive, process, and export that telemetry data. Normally, it's a single binary that can be deployed as an agent or a gateway. Delving into what's actually happening in that collector, it looks a little bit like this. So the collector is there to be able to remove the need for you to have to run and operate and maintain multiple different agents and collectors. So just by having that one single collector and then sending it to multiple different backends if you need to. It really helps to improve things like scalability, and it also supports things like open source observability data formats like Jaeger, Prometheus, Fluentbit. Again, you might be thinking, but why can't I just go straight from the sources straight to my observability backends? Why would I need to use a collector in the first place? So for trying out and getting started with Open Telemetry, sending your data directly to a backend is a really great way to get value very quickly. If you're in development or in a very small scale organization, you can also get pretty decent results without a collector. So you can try just sending it directly using the OTLP protocol directly to those backend sort of data formats. But really, we would say that in general, we recommend using a collector alongside your service because it allows your service to be able to offload that data really quickly, and the collector can then take care of additional handling for things like retries, batching, encryption, or even things like sensitive data filtering. It enables you to offload the responsibility for that to your collector instead of being within your services. So really, we would recommend if you're deploying this into things like production or a large-scale enterprise application, then we would suggest utilizing the OTel collector as that intermediate node. So that's the Open Telemetry sort of open source specification, but as it's a specification, you're going to need an implementation to actually make use of it. And this is where MicroProfile can come in. So MicroProfile telemetry is the API that you'll want to take a look at. But if you've not come across MicroProfile before, you should definitely go and check it out. It's really complementary to Jakarta EE. In fact, it has a prerequisite on it now in the latest version of MicroProfile. And you'll notice that several of the sort of APIs offered within this, in the bottom row of this kind of pyramid shape, are actually shared with Jakarta, hence that dependency. So Eclipse MicroProfile is another community-driven specification. It's a set of cloud-native capabilities that can be implemented by our Java runtimes and helps to provide, again, that kind of standard for things like application annotations, for applications to use in containers and when you're building cloud-native applications. So it helps to introduce the key characteristics and behaviors that we want to be utilizing in our cloud-native Java applications. And as I said, there's a really close synergy between MicroProfile and Jakarta EE. In fact, many of the same individuals and organizations contribute to both specifications. So there's great cohesion between them. And the nice thing about these is that you have lots of choice as to which compatible runtimes you can make use of. So you're not locked into a particular vendor. So for example, you can see here, we've got different versions of MicroProfile here from 2.x all the way up to the latest, which is 7.x. And you can see there's lots of different runtimes there that support many of the different versions of MicroProfile, sort of, as I said, in synergy again with Jakarta EE. So it's nice because if you want to lift and shift to a different runtime, you have that option because those annotations are supported across those runtimes. Now, originally in MicroProfile 6, which was where MicroProfile Telemetry 1.0 was introduced, this enabled Open Telemetry tracing. So we introduced that open source specification. So in MicroProfile Telemetry 1.0, the tracing element was enabled. It's important to note here that the other elements of metrics and logs from the Open Telemetry specification weren't enabled because we already had things like MicroProfile metrics. So if you haven't already checked it out, you can check it out, but do bear in mind that it is going to be moving into a standalone project, which I'll go on to in a minute. So here's where we enable Open Telemetry, and it allow you to be able to make use of those APIs, SDKs, and that tooling and integration directly in your Java applications. So really designed for you to be able to create those traces and manage and create that telemetry data. Now, it's changed a bit in MicroProfile 7, so this is the latest version of MicroProfile. So if you are already using MicroProfile, you may not have seen this sort of change if you're using a slightly older version. So what's happened is that MicroProfile has introduced MicroProfile Telemetry 2.0, and we've moved the metrics API from the standard stack into a standalone project, and it's expected that that's going to be deprecated in time. But essentially what's happened in telemetry is that as well as having access to the Open Telemetry tracing, we've now also got access to the metrics and the logs. So much greater synergy between those open source projects. And again, utilizing that standardization so that we can have those standards across multiple different applications. The nice thing with Open Telemetry is that it's not just Java specific. So if there are other languages that you are utilizing within your business, you can still have that standardization across the different applications. So MicroProfile Telemetry 2.0, this is pretty new, quite exciting, and allows us to take use of those metrics and logging as well. If you want to learn more about that, you can check out the sort of presentation that was done on MicroProfile 7, all the issues that were opened for each of these individual components. But essentially, as I said, it's really been introduced to allow us to be able to also utilize the metrics and the logs as well as the tracing. But in this session today, we're going to be demoing Telemetry 1.0 from MicroProfile 6. So do bear that in mind. We're just focusing on the tracing element in this session today. So in terms of how do we utilize MicroProfile Telemetry in our Java applications? So there are three different ways we can utilize this in the instrumentation of our applications. We can either use the automatic instrumentation, or we can use the manual instrumentation, or we can use the agent instrumentation. So if we're using the automatic instrumentation, that means that if we're already making use of things like Jakarta RESTful Web Services, which as a sort of Jakarta EE community, we may well be doing, and if we're already making use of MicroProfile REST client, then we can automatically enlist in distributed tracing already without making any code changes, which is great. If, however, we aren't using those, or maybe we want to add some additional tracing on top of the automatic, then we can utilize manual instrumentation. So manual instrumentation can either be added with annotations, so for example, the @ with span, or we can utilize CDI injection for things like @inject tracer or @inject span. So CDI is another API that can be introduced with MicroProfile. Or you can use things like programmatic lookup as well, so span.current. The third option is agent instrumentation. So that allows us to be able to utilize Open Telemetry Java instrumentation project to be able to gather the telemetry data, again, without any code modification. So really handy here, and hopefully limited time and effort being needed to introduce it. So how does MicroProfile Telemetry work? In a very similar way to Open Telemetry, because we're utilizing that specification. So essentially what's happening here is we have two microservices. We're collecting data from that, including that all-important context that comes with distributed tracing. Those distributed traces are composed of those spans that we talked about. That's all being sent to our backend exporter. So we're sending it to our collector and then to something like, for example, Jaeger or Zipkin, depending on what we want to be able to utilize. And this is roughly the format we're going to be using in the demo I'm about to show today. So we're all developers. We've gone through the theory. We now see that Open Telemetry is a fantastic open source specification we can make use of through things like MicroProfile for our Jakarta and Java EE applications, and that tracing and adding this all-important context into our application observability sort of strategy is really important for us to be able to understand exactly where issues are potentially occurring for our cloud-native production applications. So now that we've done the theory, we're going to take a look at, okay, how easy is this to actually implement in a Java application? And we're going to take a look at a live demo for that. So for this, I'm utilizing OpenNibity. So if you've not come across OpenNibity before, it's a cloud-native runtime. It's really designed to be very lightweight, fast, and sort of designed with developers in mind. Helps you to be able to make things like fast and iterative changes with dev mode, which I'm going to be demoing today in our demo application. Dev mode is very similar to things like Quarkus hot reload, allowing us to be able to monitor our server in real time and update our server with those changes as we go, rather than having to tear down everything and restart it. OpenNibity also makes it very easy to test. We've got integration with lots of different test frameworks and things like cloud native testing as well. And it's really designed to be ready for the cloud, ready for containers. So if you've not checked it out before, there's an article link at the bottom here which talks about sort of why cloud native developers love Liberty. And you can go to the OpenNibity website, which I'll be showing later, which has got loads of information on it all about this runtime. So today we're going to be taking a look and utilizing one of the OpenNibity interactive guides. So we have lots of free guides available on the website, all open source, that allow you to get started with and learn about lots of different open source technologies, including the Jakarta EE and MicroProfile APIs. So if you're not sure or don't know about some of those, then do go and check out our interactive guides, because we usually have a guide on each of those APIs. And as I said, free and freely available, and we have them on lots of different sort of subjects and topics from the entire range of the cloud native app development lifecycle. Today, we're taking a look specifically at the observability section, as you can see here. And the nice thing about these guides is that you don't have to run them locally if you don't want to. So we have a cloud native environment that you can run them in. So it means all you need in terms of prerequisites is a browser to be able to get up and running with these guides and try them out. So we're going to be utilizing this cloud native environment in our demo today. And in this environment, you can see we've got the instructions on the left-hand side. We've got the IDE on the right-hand side. And it's loosely based off the Thea open source IDE. And then we've got the terminal at the bottom. So we can do everything within one environment as we're progressing through this lab. So I'm going to exit from this, and let's have a look if I can switch across. Okay, I'm going to have to exit. And then switch, and then share again. There we are. Perfect. Okay. So the way that I got here is I went to the OpenNibity website. So you can see at opennibity.io/guides. So you'll head to the OpenNibity website, and then you see the guides link at the top here. So if we go to guides, and then you can see, as I said, we've got loads of different guides available. I think we've got over 60 now on different subjects. So in terms of development, but also build and test and deploy. And if you already know which one you want to take a look at, you can start filtering and searching in our search bar here as well. So if I go to the observability section, because I know that's what we're focusing on today, you can see we've got lots of guides within that focused on different elements of observability. But the guide we're going to be doing today is this second one in enabling distributed tracing and microservices with that Open Telemetry that we were talking about before. And in this case, we're using Jaeger as our backend system. So when you click on that, you'll be introduced to this page. If you do want to run any of these guides locally, you can do if you want to. Just bear in mind that you will need the prerequisites that are listed in the top right-hand corner of each of these guides. And then you can continue to follow the instructions on the left-hand side. And whenever there's code that you need, it will automatically pop up on the right-hand side for you. But as I mentioned, we're going to be using the cloud native environment. So for that, we're going to click this Running Cloud button. So when you click that, you'll be introduced to a page that looks like this. You will need to log in, but you can use a multitude of different social logins, including GitHub, for example, or you can create an account with your email. So in this case, I've logged in with my GitHub, and then you click this button, Access Cloud Hosted Guide. So that will take you to our environment that looks a little bit like this, as I mentioned, kind of loosely based on Thea. we've got the instructions on the left-hand side, the IDE in the top right, and terminals in the bottom right here. Now, the first page of all of our guides is sort of an introduction to what you're going to be doing in the guide today, and it also gives you an introduction to what the application is like that you're going to be utilizing. Most of our guides all use the same application to make it really easy for you to be able to jump between multiple guides and learn new technologies without having to actually, jump contexts in what the application is doing every time. So it's a very simple application, just to keep it simple for educational purposes. So in this, we've got two microservices. We've got the inventory and the system microservice. The inventory is essentially just a store of the inventory, and the system is scraping your system data every 15 seconds, and then the inventory is storing that information. So fairly straightforward, fairly simple, and the two communicate together through REST. So in this case, we're going to be introducing Open Telemetry to this application, utilizing the instrumentations I talked about earlier. So in the interest of time, I've already gone through and cloned this project from GitHub. Now, as I mentioned, all of these guides are freely available. So if you do want to go and check them out, you can go and check them out from the GitHub repository links that you can see in the instructions here. What you'll notice is that in our project directory, so for all our guides, we have a start and a finish repository within that. So what these are is essentially the start directory is where you're going to start from as we go through the instructions for this guide. But if you want to skip straight to the finished project, that's available in that finished directory. So if you want to try what you're going to build at the very end by going into the finish, you can do that. And there is instructions for that in the first part of this guide. But we're going to start from the starting point and work through those instructions to sort of work through the steps that are needed to be able to introduce Open Telemetry. Now, in order to have Jaeger up and running, ready to sort of be able to showcase and collect and store the data that we're instrumenting in this guide, I did run this Docker command already. So this is getting that Jaeger server up and running. And again, the nice thing about doing it in this cloud native environment, this IDE, is that we've tried to make it as easy as possible for you to implement and utilize the instructions. So we do have copy buttons available, or just straight away executing buttons that will automatically execute it in your terminal for you. So it makes it super easy to follow these instructions. And then we've also given you links as well. So this gives you the link directly to your Jaeger service once it's up and running. So you can see I've got it up and running, but right now I've got no services because I've not enabled any telemetry data yet in my application. So nothing there yet. So let's take a look at, so we're not going to do this in terms of going to the finished directory. If you'd like to do that in your own time, you absolutely can. We're just going to go straight to the start directory so that we can start following these instructions. Now, again, in the interest of time, I've already run these Maven commands to get my two servers up and my services up and running. In this case, we're utilizing the Liberty dev mode. So as I mentioned earlier, it allows us to be able to have that hot reload functionality. So it means our server is always listening out for changes to our configuration and our code. So it's able to sort of recompile those particular classes instead of having to tear down our entire application and redeploy it. It saves us a lot of time in that development stage. It enables very agile methodology in terms of developing our applications. So I've already got them up and running. You'll know when it's running in dev mode. You'll know it's up and running when you see, let's take a look at where we are. Here we are. You'll know it's up and running when you can see this line of stars and the message, Liberty is running in dev mode, as you can see in the instructions here. So I've already started the system microservice in this terminal and the inventory microservice in this terminal, as you can see from my naming here. So in order to do any more commands like the curl command that's coming up next, I'm going to have to open another terminal because these two terminals are now taken up by my server listening for changes. So I can do that by going to terminal, new terminal, to open up that new terminal. So now that we've got the runtime instances started, we can now find the system service by running the following curl command. So if I do that, you can see some of my system data being scraped there, and I can do the same for the inventory here as well. Okay, so the first step in enabling MicroProfile telemetry in our microservices in our application is that when we're going to need to replace the server.xml that we have for our microservices to be able to enable the MicroProfile telemetry feature in them for this configuration. So again, you can either go and manually find the files or the classes yourself, or you can just use our sort of magic buttons here that will automatically open it in your IDE for you. Just going to open this up a little bit so you can see it better. And again, you can either go through and manually find the particular feature that we're adding or the line of code we're adding, or if you want to sort of mitigate the risk of adding in bugs, you can just copy the whole class that we've given and delete everything that's currently in that class, paste and save. Bear in mind, in this environment, there is no autosave, so you will need to manually save as you go along, but you'll know if it's not saved if there's a dot in the top right-hand corner of the file name. So in this case, as mentioned, what we're doing is adding in that MicroProfile telemetry feature to our server.xml to enable it for, in this case, in the system service. So that's the one we've updated first. We'll also need to do the same thing for the inventory service. So again, I'm just going to add in the whole of this code, save it as well. So you can see we're just adding in that MicroProfile telemetry feature. It's a little bit odd, but after we've done this, the next thing we need to do is actually enable MicroProfile telemetry, because kind of weirdly, by default, MicroProfile telemetry is off. So to be able to enable any tracing aspects, we have to specify that we want the OTel properties in the MicroProfile configuration file. So we're now utilizing another MicroProfile API, which is that MicroProfile config, which allows us to be able to have external configuration from our code, which is really best for sort of cloud native applications, to be able to deploy it to various different environments. So for example, development, staging, production, or different clouds, for example. So in this, we're going to open up the MicroProfile config properties file that we already have for the system microservice. We already have it for the inventory, we don't have it for the system. So we're going to use this touch command, which again, I automatically executed to be able to create one. So now when we open it up, we should see it's empty because we've just created it. And then we're going to copy and paste in the different properties that we need for this. So what we're doing here is we're setting the OTel service name. So in this case, it's for the system microservice. So we're just naming that system. And we're enabling this important one, is we're enabling that disabled to false, which enables Open Telemetry to be able to be used. We're also setting the exporter property to none to disable metrics. And we're setting the exporter property to none to disable those logs. So again, that's in reference to the newer version of MicroProfile, which has telemetry 2.0, but we're just focusing on tracing in this particular guide. So now we need to do the same, but for the inventory microservice. But in this case, we already have a properties file for that. So if we copy and paste and delete what was in there originally and replace it with this, again, you can see we're just adding in exactly the same values, but in this case, changing the name to be inventory because this is for the inventory service. But again, disabling that false so that we can enable Open Telemetry, and we're not using the metrics or the logs here either. So now that we've done that, let me just get rid of this, we can now run this curl command to essentially be able to view the automatic traces that we've already enabled. So you can see all I did there was enable it in the server.xml and utilize MicroProfile config properties to enable Open Telemetry to actually be used in this application. Because we're already utilizing MicroProfile REST client and CART-EE RESTful, we can already make use of that automatic instrumentation without making any code changes within the code of our application. So now that I've done this curl command, I can go back to my Jaeger UI. If I refresh that, now what you'll see is you can see we've actually got our microservices in there. So if I just go to system or inventory, and then if I say find traces, what you can see is we've already got traces automatically enlisted without making any of those changes. We can start to click on them and get some information about what's been happening within that trace, for example. So again, super easy to get started with that automatic instrumentation. Now, the next step, and again, the instructions just take you through what you should be seeing in that Jaeger UI. The next step is to enable explicit distributed tracing. So this is using that manual instrumentation. So we've already done the automatic instrumentation, and the next one is to add manual instrumentation to the source code. So for this, we're going to be utilizing the app with span annotation. If you're familiar with CART-EE and MicroProfile, you'll be familiar with utilizing annotations within your applications. We can also use things like the CDI injection, so we can inject a tracer to be able to create and customize spans as well. So for this, we're just going to open up the server.xml for the inventory service. And again, we're going to be adding some stuff to this class. If I open that up, copy and paste, what you can see here is that we're exposing Open Telemetry APIs as third-party APIs in OpenLiberty. to be able to add the visibility of Open Telemetry APIs to the application, we need this third party. So you can see here API visibility. We need this third party type for the particular server.xml. So now that we've done that, we can go and start enabling tracing into Jakarta CDI beans. So you can trace with CDI beans by annotating them with this with span annotation. So now if we open up our inventory manager, this is where we start to introduce those annotations into our classes, into the code of our application, hence the manual part of this instrumentation. So again, if I copy that and again, select everything, paste and save, what you can see here is that we've started to add this with span annotation, where we're adding in the fact that we want to create tracing within this class for the list and the add methods, which can accept an optional parameter that functions as a span name, for example, as well. So we've got things like span attribute, where we're adding in that information. Which is essentially this additional annotation that we're making use of allows us to be able to include specific parameters. For example, what we're doing here is specifying a host name as the attribute for the host parameter, which then helps the trace to then trace the parameter within the add span. Again, you can check out all of this within the Open Telemetry annotations documentation if you want to go further into it as well. So if I just get rid of this again. So now if I enable that curl command, tell you what I haven't done is saved. So do make sure you save. You can see this dot in the top right hand corner. It means I haven't saved, as you can see. So if I run that curl command again, now when I go back to the Jaeger service, just as well I caught that. Now when I go back and I refresh, and then we do find traces. Let's take a look at what I should be at because I'm not on the inventory. Let's go to inventory, find traces. Yeah, what you can see is I've now got additional traces that I've been able to add in with those annotations through the manual instrumentation using the Open Telemetry specification, which was enabled through MicroProfile tracing. So you can continue with these instructions if you want to. I know that I'm getting close to time here, so I'm going to wrap up my demo here. But if you're interested in trying this for yourself or going further and taking a look at implementing it with things like agent instrumentation, that's enabled in this, or injecting with a custom tracer, for example. All of that's enabled within this guide, and you can continue to follow this through all the way to the end, where we run some tests just to ensure that our application is working as expected. But as you can see, in just 5 minutes, I've been able to not just only use the automatic instrumentation, but also start adding in some manual traces with those annotations through MicroProfile telemetry. So really making it easy to be able to implement distributed tracing within our MicroProfile and Jakarta EE applications. Do bear in mind, if you are going through these guides, you will need to do some cleanup at the end. Otherwise, you might have issues if you're jumping from one guide to the next. So make sure you're following all of our instructions to clean up your environment afterwards. And do let us know if you do have a go with this guide, what you think, because we're always looking for improvements, or if we're missing a guide, looking for ideas on things that we might be missing that we could always add to the website. So do let us know. Okay, so going back to my slides, let me check that I'm able to see that. I'm going to stop sharing and then reshare so that it comes back. And grab the right slide up. There we are. So we're right down to the summary and then share. Perfect. Okay, so hopefully, not sure why it's showing that. Let me stop and present again. There we go. Perfect. There we are. So hopefully what I've shown in this session today is that we are entering a world of increased complexity, but we can learn from things like the world of medicine and the world of biology, and learn from the fact that we do need to be sort of implementing things like that all-important context to be able to effectively observe our applications. And that effective observability is really critical to be able to monitor and effectively understand how our applications are behaving in the really complex environment of the cloud. And that context is critical in that effective observability. But the nice thing is that it's not all down to you. There are many open source tools and technologies available to help us as we're trying to sort of become those cloud native physicians and utilizing things like Open Telemetry. So if you do want some additional resources, I've got some links here. What is observability? This just sort of highlights kind of those key steps that I was talking about at the very beginning of how do you enable observability in your application. And if you want to go over more of the specific Java related content, then do check out links 2 and 3 here. If you're interested in learning more about Open Liberty and you want to find out more about it and find out when our guides are released, for example, or any other sort of educational resources we have, we are available on social media. I run the social media, so I'll say hi if you come and give us a follow, or feel free to give us your feedback through social as well. So do connect with us either through LinkedIn or Twitter or X. And with that, I'm going to say thank you so much for bearing with me. Hopefully you found this interesting, and do go and have a go with the slides or the guide yourself if you are interested in getting hands-on with this and trying it in your own enterprise Java application. Thanks, guys. Really appreciate your time today.
Thank you so much, Grace, for that excellent presentation. So just a final reminder, and anybody in the audience that has any final questions for Grace, we will be able to answer them. While we are wrapping up to that, just a quick little reminder with regards to the survey. So we'll just put that back up quickly here for you. So you can just scan the QR code, take the survey, participate, and we would greatly appreciate that. So Grace, I'm looking at the chat, and there is no questions in the chat or the Ask a Questions tab. The questions that are in there are irrelevant to your presentation. So if there is anybody that has any questions, please feel free to reach out. We are happy to assist you in answering any of those questions. Thank you again so much, Grace, for your time today, and we look forward to seeing you next week. Again.
Yeah, I'm excited to be back so soon.
Amazing. We can't wait to have you. Thank you so much.
Thank you.